If you're in chemistry and you want to just do a quick little review and see how well you know the equilibrium acids and base unit, here's a worksheet you can download from my website. It's 20 questions and it would also help you prepare for the diploma. So let's get started here. The first question is asking about dynamic equilibrium. So this is essentially showing that you know the definition of equilibrium. And so the first one, hopefully we can rule that out, because saying the reaction stops completely, that's not equilibrium. The forward and reverse reactions occur at equal rates. That definitely is going to be our answer. And looking at the next few, the concentrations of reactants and products are always equal. That's not the case. And only the forward reaction continues. That's not the case at all. So if you're in equilibrium, you can approach the reaction from either the left or the right because it's constantly moving. Our next one, number 2, is we have the equilibrium system, and it's asking what would happen if you add in hydrogen gas. So this is showing that you know Le Chat's principle and what way we're going to shift. So if we add in, you shift away. So we are going to shift to the right. Number 3, this one is asking if you increase the temperatures of an exothermic reaction, what way would you shift? So if you're exothermic, your heat, so this would be your reactant side, the product side, your heat would be on the product side. So if you add in heat, you shift away. So all exothermic reactions, if you add in heat, you shift to the left. Number 4, we are looking at what would happen if you add in a catalyst to the reaction. Catalysts do nothing to the equilibrium constant. It does not shift to the left or the right. All it does is increase the reaction rate. So it will get us to equilibrium faster. If we're in equilibrium, we're moving just faster between the reactants and products. Number 5 is showing that you understand the Kc expression. So if your Kc is greater than 1, so Kc is greater than 1, your products are favored. So this one is greater than 1, so products are favored. If your Kc expression is less than 1, your reactants are favored. So in question 6, because we have a very small number, right, with this negative exponent, we are going to choose B. And if your Kc is equal to 1, just to add on here, that means nothing is favored. So the reactants and the products are going back and forth at the same time, essentially. Number 7. Which substance is not included in an equilibrium constant expression? So gases are included, any aqueous solutions included. What is definitely not included is pure solids. So if you add in a pure solid, it's not going to affect your equilibrium. Number 8, we have our equilibrium expression. We're adding NaClAq, which means you're adding the Na ion and the Cl ion to the system. So we're directly, in this case, adding in chlorine. So if you add in, you shift away. That means you're going to shift to the left. So in terms of this question, though, it's not asking about the shift. So it's saying, will you increase the solubility of AgCl? Well, that's not true. There won't be any effect because we are adding in, so there will be a shift. But because we're shifting to the left, that means we're making more AgCl. So it's causing AgCl to precipitate, meaning you are making that solid. It's not decomposing AgCl because we're not shifting to the right to its ions. Number 9, if we are using an ice table, what we are determining is not the reaction rate. We are looking at equilibrium concentrations. We're not looking at oxidation numbers or pH. So I'm not sure what happened to the formatting here. But when we're looking at an ice table, right, initial concentrations, the concentration change, and lastly, your equilibrium concentrations. So when you do the ice table, it is the part at equilibrium that starts to let you figure out those missing concentrations or your Kc value. Number 10, a saturated solution. So if you have a saturated solution, right, we know that we have some sort of soluble ionic compound that we're adding in, so it's dissolving, and then if it's saturated, it means you still see some crystals at the bottom, and while these crystals are forming the ions will be forming the crystals. So that's what our saturated solution is. So going through these options, contains no dissolved solute. Well, there is a dissolved solute, that would be all of this area, not including the solid. Contains the maximum amount of dissolved solute, at a given temperature. That one looks like it could be true, but let's just check the next couple. Contains only solid solute. That would mean this part here, so that's not true. And contains only products. That's not true either, because this is a system in equilibrium. So the best answer definitely is B. Number 11, which of the following is a strong acid? So for number 11, just look at your acids table in your data booklet, and whatever is above the gray line is your strong acid. And the one that is above the gray line here is HCl. Number 12, which of the following is a weak base? So weak bases do not contain OH. If you see the OH ion, you are a strong base. So the only option here was ammonia, which is C. Sorry, it's just catching up with me here. There we go. Let's move up. Number 13, if your solution has a hydrogen ion concentration of the value that is given, what is the pH of the solution? So with question number 13, you could just take the negative log of this number, right? So the pH formula is negative log of the hydronium concentration, but really because hydronium and hydrogen are very similar, just because hydrogen is a very small ion, it will bind with water and make hydronium. We can kind of consider it to be the same thing. So put that in your calculator, just substitute that value in, and you'll see that your answer here is A. Your pH will be 3. Number 14, if you have a pH of 11, if you wanted to find pOH, this hopefully is a nice easy question for you, because this is more of a beginning question in terms of chemistry. We just are going to subtract that value from 14, and we'll see our answer here is C. Number 15, if you have a solution with a pH of 2, just to be able to describe the solution, is it strongly acidic, neutral, slightly basic, or strongly basic? Well, if you're a pH of 2, you're on the acid side, so you can take that out, you can take this one out. So the best answer here is A. Number 16, which statement is true? Strong acids completely ionize in water. Weak acids completely ionize in water. Strong acids have a very small Ka, and weak acids always have a pH of 7. So definitely D is not true. C is also not true. Strong acids have a very high Ka because your reaction is going to completion. So products are not just favored. You have quantitative reaction. You have all products. So between A and B, strong acids will ionize completely to form only products, right? You're going to split into your ions. Whereas weak acids, they do not ionize completely. They just make a very minimal amount of products, and we definitely are laying on the reactant side. So your only answer here is A. Number 11, understanding the definition of buffers. They contain a weak acid and its conjugate base. So you have to have only weak acids and bases present, because if there's anything strong, you're not in equilibrium, and we need to have it to be in equilibrium to be able to be a buffer. So that's really just showing the definition. Number 18, the equivalence point of a strong acid with a strong base is going to be 7. If you're mixing it with a weak base and a strong acid, that changes your equivalence point. Same thing if you have a weak acid and a strong base. So just knowing those 3 particular pHs for the equivalence point. Number 19, again, I'm not sure why the formatting is doing this, but which quantity is used to measure the strength of an acid? Hopefully here we know right away that is Ka, and the higher the value of Ka, the stronger your acid is. Number 20, according to Lechat, when a system at equilibrium is disturbed, it will not always shift in one direction, so we can't say it's A or B, but will it shift to oppose the disturbance? That is what Lechat is. That is its principle. So if you disturb an equilibrium system, it wants to shift to recover and go back into equilibrium. So you always go into the opposite direction to where the disturbance was. This last one here is just a very quick showing understanding of terms of what way you are shifting. So if you have the system that's given here and you increase the pressure, so here, if you increase pressure, you are decreasing volume and you move to the side with less moles. So your left-hand side has 4 moles in total. 1 plus is 3. Your right-hand side has 2 moles in total. So you are going to shift to the right. The next one here, if you increase the temperature, it's exothermic. If you increase, you shift away. So that would mean you are shifting to the left. If you remove NH3, so if you take this out of the system, you want to shift to the right to replace it. And lastly, if you add your nitrogen gas, so if you add in, you shift away. So that is also going to be to the right. So here's again a very quick review, a snapshot of some of the theory. There's definitely more that was covered, right? Like knowing how to actually set up your ice chart, and there's many other things that we can take a look at. But this is showing a bit of an understanding. If you did find this video helpful, please subscribe. And if there's any other video I can do for you, just leave me a comment. Thanks for watching.